This is from the other Wikipedia page, History of Solar System Formation and Evolution Hypothesis. I will link this to the bottom of this talk. Look up Part 3, the Solar Evolution Hypothesis. I'll go ahead and read out a sentence and give an interpretation of what the sentence is actually saying in light of, the theory I'm developing. Attempts to isolate the physical source of the sun's energy and thus determine when and how it might ultimately run out began in the 19th century. Okay, if you notice, they say attempts to isolate the physical source of the sun's energy. What that means is make it mathematical. They wanted to isolate it, not realizing that if you're going to explain how something as massive as the sun loses energy, it's not going to be something that you can isolate with a math formula. There are going to be a lot of different complex processes happening inside the sun, such as plasma recombination, exothermic reactions from chemical combinations, heterolysis, meaning the breaking apart of molecules and then the reforming the molecules back again in combination reactions. Various processes. You cannot isolate the source of a star's energy. It radiates and is thermal and a whole bunch of different mechanisms. So, yeah, isolating, not a good idea. At that time, the prevailing scientific view on the source of the sun's heat was that it was generated by gravitational contraction. Understandable. If something is that large and has a whole bunch of gravity, that energy has to go somewhere. It just doesn't disappear. In the 1840s, astronomers J.R. Mayer and J.J. Watterson first proposed the sun's massive weight causes it to collapse in on itself, generating heat. An idea expounded upon in 1854 by both Hermann von Helmholtz and Lord Kelvin, two very intelligent gentlemen, who further elaborated on the idea by suggesting that heat may also be produced by the impact of meteors into the sun's surface. Well, that should have been their clue. The impacting of meteorites on the sun's surface didn't exactly generate all the heat. What was happening is that the sun was accreting material from outer space, because stars are the locations for accretion of matter. In other words, the star is the place that planet formation occurs. However, the sun only has enough gravitational potential energy to power its luminosity by this mechanism for about 30 million years, far less than the age of the Earth. This collapse time is known as the Kelvin-Helmholtz timescale. Well, that's very, very close to the truth. It only does power the sun for very short periods of time, but they didn't have plasma in their toolbox. They didn't have MHD or EMHD in their toolbox, electromagneto-hydrodynamics, the fluid motions of plasma, how it behaves, recombination from plasma to gas and gas back to plasma again via ionization, critical ionization velocities of the material, circuit forming, capacitors inside of the solar atmosphere and how they store and release energy. None of that was in this description of the sun's mechanisms for how it was powered. That was formed when Hans Alfvén started working on the sun back in the 60s. So they were getting ahead of themselves, so to speak. They were trying to force an answer onto something that really they should have left it alone. They should have said, well, 30 million years, well, that means the sun's younger than the Earth. And that would have made more sense, because that's very true. The Earth is vastly older than the sun. It's a much more highly evolved star. But, as you'll see here, Albert Einstein's development of the theory of relativity in 1905, no, that's special relativity in 1905, not general relativity. General relativity was in 1915. Led to the understanding that nuclear reactions could create new elements from smaller precursors with the loss of energy. I don't see any problem with that. In his treatise, Stars and Atoms, Arthur Eddington suggested that pressures and temperatures within stars were great enough for hydrogen nuclei to fuse into helium, a process which could produce the massive amounts of energy required to power the sun. That's where he really screwed the pooch. He assumed fusion to occur inside of stars without actual locations of the fusion reactions which occur in outer space, inside of active galactic nuclei. It takes galaxies and energies and velocities to fuse matter. Stars, they're not hot enough. They're not pressurized enough. They're essentially too weak, too dull to create nuclear reactions on the fusion level, where hydrogen combines to make helium, or helium combines, and you get heavier and heavier elements. That process occurs inside of birthing galaxies, not inside of stars. But the reason why Eddington forced it to be that way is because, well, he just simply didn't have the active galactic nuclei or quasars or radio jets in his toolbox. He did the best he could with the information that he had at the time. In 1935, Eddington went further and suggested that other elements might also form within stars. So he goes even further down this wrong path of theorizing. Spectral evidence collected after 1945 showed that the distribution of the commonest chemical elements, carbon, hydrogen, oxygen, nitrogen, neon, iron, etc., was fairly uniform across the galaxy. This suggested that these elements had a common origin. Yes, they came from the center of the galaxy when it was being born. That is the common origin. A number of anomalies in the proportions hinted at an underlying mechanism for creation. Lead has a higher atomic weight than gold, but is far more common. Hydrogen and helium, elements 1 and 2, are virtually ubiquitous, yet lithium and beryllium, elements 3 and 4, are extremely rare. I'm not too sure what that's supposed to prove. But anyways, that is the issues. Those are the issues we have here. We have ideas that were invented, people going too far before they had enough information, and now we have this dogma that exists that just won't go away. So we're going to be building fusion reactors that aren't going to work because we never explain the stars in their proper light, in the way they're supposed to be explained. So you have the laser reactor not working, you have the ITER, which is going to be spinning, they're going to be spending billions of dollars building this giant tokamak, which isn't going to work. It's obvious this stuff isn't going to work. I guess they're more concerned with money out of contracts and things like that. They're not interested in science anymore. If they were, they would have seen where we went wrong and corrected it immediately. As well, on this page, the history of solar system formation and evolution hypothesis, we can see the main issues here. Now, they have the alternative theories as well as the accepted theories, all basically reliant on the same philosophy. The philosophy that planets and stars are mutually exclusive. You have tidal theory, the Chamberlain-Moulton model, Littleton scenario, band structure model, interstellar cloud theory, Hoyle's hypothesis, Kuiper's theory, Whipple's theory, Urey's theory, protoplanet theory, Cameron's hypothesis, capture theory, solar fission, Herndon's model, and you have the bottom of the classifications of the theories, where they try to classify the different theories based off their main root philosophy. But they forgot one single thing. The main root philosophy that is more rooted than what they think the philosophies are rooted in is the fact that they have stars being mutually exclusive of planets, but they're not. All these theories all try to make stars and planets as something different from themselves. From really hot, big, bright stars to the really old, rocky, small ones that have lost most of their mass and energy, that have evolved to the point to where they no longer radiate anymore, have things like lava and life and water and things like that. But that's their main problem. So no matter how many alternative theories you come up with, if you keep the star as mutually exclusive of planet, you're never going to understand how this works. And it's a very, very big change from what we were taught to believe back in the 18th century, 19th century, and the 20th century. So keep that in mind when you look at this page. Notice that they all have the same root philosophy, and that's the main issue here. As well, keep in mind that a lot of these ideas were expounded upon before there was enough information. So they made things true before there was any evidence of them being true, all because they had the positions and the power in society to do so. Einstein and Eddington were pretty popular, so everybody went with them. They didn't question their ideas. And as a philosopher of science, if you question them, you got excommunicated from your groups, and you got ridiculed, and you got cast aside as if you were some idiot. And I'm sure that happened a lot. But now that we can question these people and their motivations, and it's very easy for me to go against this because I have a much superior theory than all these other people combined, all because I've changed the philosophy, well then. Now, you guys know the theory. You guys can work on it as much as you want and make it even better than anything that I could have ever imagined. But keep that in mind. Just look at the history behind why things are the way they are. You'll be surprised what you'll find. Today is August 29th, 2015.